Hello. We are continuing our discussions on calculations, and this is from the Pharmacy Technician textbook, 5th edition. And this is the Pharmacy Technician course offered by Excel Career School. Okay, there's a few things that we're going to look at. Again, this is dealing with calculations. We're going to look at numbers, fractions, decimal numbers, significant figures, measurement, equations, and variable, ratio and proportions, percents and solutions, allegations, powdered volume, children's doses, calculations for business, and then do a short review. So, some of the things that you should be familiar with by the time you finish this particular chapter, and these will be your learning objectives: to be able to define numerator, denominator, and fraction, perform mathematical operations to solve problems with fractions, perform mathematical operations to solve problems with decimals and percent, describe measurement systems used in pharmacy, perform mathematical operations to solve problems that involve different units of measurements, use ratios and proportions to solve problems in pharmacy, use the allegation method to solve problems involving two different strengths of the same ingredient, use powdered volume to solve problems with powder for reconstitution, describe considerations for children's doses medication, and be able to perform basic calculations associated with the business aspect of pharmacy. So we have begun each chapter looking at thinking through, and then we'll go back and talk about it at the end. Michelle has worked as a pharmacy technician in a community pharmacy for 5 years and is now starting to work as a pharmacy technician in a hospital. She was confident in her skills to perform the necessary calculations in the community pharmacy, but she knows that she will need to develop skills to solve different types of problems in the hospital. As you read the chapter, keep in mind the following questions. 1. What are some of the calculations commonly performed by pharmacy? What types of calculations are commonly performed by pharmacy technicians in hospital pharmacies? Why is accuracy in calculations important in both environments? Okay, let's begin our discussion looking at Roman numerals. Roman numerals are very important in medicine. Remember when we went through the history of medicine, that the Roman contribution, for example, the physician Galen made a significant contribution to westernized medicine. And so some of the things that you see is SS, which means 1/2, I, which is 1, V, either capitalized or small, that's 5, and X, either capitalized or non-capitalized, is 10, L, that's capitalized or not capitalized, is 5, C, capitalized and not capitalized, 100, D, capitalized and not capitalized, 500, M, capitalized and not capitalized, is 1000. Usually the numbers are capitalized dealing with Roman numerals in a pharmacy or scientific setting. Okay, so let's look at the position notations associated with Roman numerals. When the second of the two letters has an equal value 2 or smaller than the first, we add the values. For example, IXBI, this is supposed to be L here. This is 50 plus 10 plus 5, which is 5, and plus 1, which is I, gives you 66. When the second of the two letters has a value greater than the first, we subtract the smaller number. And for example, here, C is 100, X is 10. So the 10 is subtracted from 100. This is 90. Okay. So looking at some of these practice problems, you see we have here x10 plus 5 plus 3, which is equal to 110. The previous example that we had x in front of the c, which came out to 90, but if x was past the c, is 110. Then we have a capsule number, and then x, I, b. I, the small number, is from the b, so this is 14 and not 16. Let's go ahead and look at fractions. And when we talk about fractions, we talk about something that has a numerator and denominator. Numerator is the number that's on top in the fraction, and we will go into that when we have some examples. Denominator is the number that's on the bottom. Reciprocal is the opposite of the fraction. For example, if you have 1 over 3, the reciprocal is 3 over 1. And we're going to talk about how to add and subtract fractions and how to multiply and divide fractions. Okay, let's look at some examples. Right, so fractions can be turned to decimals. So 1/3. Notice the 1 is the numerator. There's a line, and then 3 is the denominator. And this is in essence 1 divided by 3. And you get a decimal of 0.33. And if you turn that to percentage, that would be 33%. Here, 1 over 2 is 0.5 or 50%. We add in, if the denominator is the same, you just carry it over. So 1/4 plus 1/4 equals 2/4. And this can be simplified to 1/2 or 0.5 or 50%. Here, you have your denominator that's not the same. Therefore, you have to find the smallest number in which both denominators can go into. Here is 12. And so, if you did the math, what you will have is the following. Okay, so if you made this 12, so how many times does 4 go into 12? 4 going into 12 3 times. Okay, how many times does 3 go into 12? 4 times. Maybe 4 times 2 would be 8. So now you have 3 12 plus 8 12. Now I'll give you 11. We're subtracting the fractions. Again, to do so, you must have a common denominator. Right? So here is 6. 3 going to 6 2 times. 2 times 2 is 4. Here we have 6. 2 greater than 6 3 times. 3 times 1 is 3. So you have 4 6 minus 3 6 is equal to 1 6. If the denominator is the same, then the denominator carries over. So 2/3 minus 1/3 is equal to 1/3. When multiplying fractions, all you have to do is multiply each number. So 1/4 times 1/4 is 1/16. Here, if numbers are different, denominators are different, you just multiply straight across. So 1/4 times 2/3 equals 2/12. This can be simplified to 1/6. If you divide in the number fraction, it would be 2/3 divided by 1/2. You now do the reciprocal. So you have 2/3 times, and I switch this above. So that comes out to 2/1. So this will be 4/3. And this can be turned into a mixed number, which has an integer plus a fraction, or 1 1/3. Right? If I'm dividing the number, okay, again, 2/3 divided by 3/3, I have to switch the second number around. It is reciprocal. It will be 2/3 times 3/1, which is 6/3, and the answer will be 2. Okay? Now, let's go ahead and talk about decimal numbers and how we are to work with decimal numbers, multiplying decimals, and we go talk about significant figures. Okay, so we'll add in decimal numbers. So when you add decimal numbers, you want to make sure that your decimal is in the set place. Okay, so here in our particular example, we have 0.6 plus 0.5 plus 0.4. When you put that together, it comes out to 1.5. Okay, you may see it in this particular manner. Here, you make sure that the decimal points are lined up. Okay, so 4 plus 9 is 13. So 1 plus 3 is 4. 2 plus 9 is 11. So this is 21.43. In subtracting decimals, again, you want to make sure that the point is lined up. So it would get 10 here. So it'd be 14 minus 9 is 5. This became 2. 2 minus 0 is 2. Then 12 minus 9 is 3. And all the decimal lines up. Here, it's supposed to be problem number 4. 0.5 times 0.7. When you're multiplying decimals, you take into consideration the amount of space behind the decimal. And so this comes out to 0.35. Okay? So there's certain rules that you should be familiar with in relationship to significant figures. For rules for assigning significant figures, 1. Digits other than 0 are always significant. Final zeros after the decimal points are always significant. Zeros between two other significant digits are always significant. And zeros used only to space decimal are never significant. Okay, so what does this mean? So here, when we talk about digits other than 0, we talk about the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9 individually. So always significant. The final zero after the decimal point are always significant. What does that mean? If you have something like 4.0, then that 0 is significant. Or if I have